Okay, what we're looking at is Chapter 8's Inquiry Lab, Inequalities, and it's on page, it starts on page 615. It begins by having the inquiry, how can bar diagrams help you to compare quantities? And it has an example here. In saltwater fishing, any flounder that is caught may be kept if it is greater than or equal to 12 inches long. Any flounder shorter than that must be released back into the water. Pat caught a flounder that is 14 inches long. He wants to know if he can keep the fish. Let's just point out some of the important things that are in here. Let me get my highlighter tool here. So some of the important things, it says that you may keep it if it is greater than or equal to 12 inches long. And he caught a flounder that's 14 inches long. Okay? If it's shorter than that, you're supposed to release it back into the water. I don't know if any of you have been fishing, but I have heard about this. If you ever watch that crab fishing show, they always have like measuring, and they throw the small ones or the ones that have too much barnacles on it or something like that. Deadliest catch, that's what it's called. I used to watch it a long time ago, and I remember they'd always have this tool that would tell them how big they needed to be and stuff for certain crabs, I guess, so they didn't catch the babies. Alright, so hands-on activity says an inequality is a mathematical sentence that compares quantities. An inequality like x is less than 7 or x is greater than 7 or than 5 can be written to express how a variable compares to a number. So the first step is that we're going to label the minimum length the flounder can be. Okay? So this is our minimum length of the flounder. It's 12. Okay? So the first thing that we're going to do is mark that it's 12 inches. Alright, then it says labeled the length of the flounder that Pat caught. So Pat caught a 14-inch flounder. Right here, this is the size of the flounder. And so the bar representing Pat's fish is blank than the bar representing the minimum length that can be kept. And hopefully you see that, in fact, Pat's fish is longer than the bar, because this is our 12 inches and this is where we landed. So we are beyond the minimum. So Pat blank, keep the fish. Hopefully you know that Pat can keep the fish. Alright. So now on the next page we're going to do some examples. Model with mathematics. We're going to draw a bar diagram to solve each problem. So for flights within the United States, luggage must be no more than 100 no more than 50 pounds. Imelda's luggage weighs 53 pounds. Can she take the luggage on her flight? So we know that it can be from 0 to 50 pounds. This is the amount that we can have for luggage. And this is where Amelia is. Can she take her luggage on the flight? The answer is no. Unfortunately, she needs to lose 3 pounds of her luggage. And I don't know what she's going to do. Maybe get rid of all her makeups? I don't know. Number 2, Byron needs at least 20 minutes between the end of his soccer practice and the start of his dentist appointment. His practice ends at 4:30 and his appointment is at 5. Does he have enough time? I think the first thing we need to do is figure out how much time does that make. Alright, if we've got 4:30 to 5, how much time is that in minutes? Hopefully you know that that is 30 minutes. Okay, so here's how long he has, and he needs at least 20, which is right here. So does he have enough time? Yes, he's actually going to have a little overage time here of 10 minutes. So the answer is yes. Number 3, which inequality is used when the situation involves a minimum? So now we're trying to figure out, is it less than or greater than when there's a minimum? If you look back at the last couple of examples, minimum, all right, so let's say we've got, here's our number line, and we had to have a minimum of 12-inch fish, right? So a minimum of 12 inches. What do we need to have in order to be able to keep it? We need it to be, do we need it to be lower than, or do we need it to be more than? And hopefully you know that we need it to be greater than 12. So the answer we're looking here is greater than. So when we say the word minimum, think greater than, okay? And look, do you notice anything about this arrow? If it's going this direction, if your answers are this direction, your alligator is already showing you. Okay? Greater than. That's just a little trick I use. That only works sometimes, and I'll show you how to use that to your advantage. So number 4, it says, which inequality is used in the situation involves a maximum? So again, here we go. Let's say the maximum was the 50 pounds of luggage. Okay, that was the maximum, and you could not have any more than that. So if I'm saying maximum, does that mean that I can have less than 50, or can I have more than 50? Well, hopefully you know this is what we're talking about over here. It needs to be less than 50 pounds, because we're looking for an amount over here between 0 and 50. Anything above 50 is going to be a no-no. Okay? So when we see the word maximum, we think less than.